Hi, welcome everyone. In this series of videos, we are going to learn programming concepts of ARM 7 using Keil Microvision. We will be writing programs for LPC 2148 microcontroller. In this video, we are writing a program to find sum of first 10 integer numbers. Let's get started. So whenever we start writing a program, we start with directive called as area. The detailed explanation and usage of different types of directives in ARM microcontroller is discussed in my previous video. Please watch in order to understand the execution of the different types of directives or usage of the different types of directives. So in order to start a program, first we need to define area within memory, then give area name, example which program. As we are finding sum of first and integer numbers, give name as area name as sum. Memory of area is code memory. We are writing code in that area of sum. Next, code memory is read-only memory. The next directive, entry, indicates it is a code entry point. And the next directive, which indicates start, is the start of execution of instructions. So in this program, as we are adding first 10 integer numbers, that is the numbers from 1 to 10. So it will be addition of 1 plus 2 plus and continues till 10. So where the result will be equal to 55, that is sum of 10 integer in decimal. In microcontroller, values will be in hexadecimal. So the equivalent of 55 in hexadecimal is 37. So it will be displayed as 0x37. So the numbers which are displayed here in the ARM microcontroller is a 32-bit value. So the first instruction what we are starting here is move R0 is equal to 10. So this instruction copies the value 10 into the register R0. So we are setting the counter which is equal to 10 in order to count or use the counter for adding the numbers. Next, initialize the registers to store result. So the result will be stored in register R1, where initially R1 is equal to 0. Take the first number to add. That is 1 will be taken and it will be copied into the register R2. Then add the numbers R1 plus R2, that is 0 plus 1, and store the result in register R1. So now R1 will be equal to 1. You are incrementing the integer where R1 is equal to 1 and you are decrementing the counter which is R0 equal to 9. So this and the next instruction is branch not equal to next. Next is a label which will go to the add instruction. So this loop will be executed until R0 reaches 0. So here R0 is not equal to 0. So it will go and execute the instruction. Now the values of R1 will be equal to 1 and R2 will be equal to 2. And so it will be 1 plus 2, which will be equal to 3. So next, R1 will have 3, R2 will have 3, and the counter is decremented to 8. So now, even now, the R0 is not equal to 0. So again, it will execute the instruction. So let's see how this is executed using the two loops. I have taken an example. So as discussed, it is sum of 10 integer, that is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, which is equal to 55 in decimal, and in hexadecimal it is 0x37. So now here the counter is equal to 8. So next, it will take the value where R1 is equal to 6, R2 is equal to 4, incrementing the integer and decrementing the counter to 7. So now the 6 plus 4 will be added, where in the execution of the next loop, you have R1 is equal to 10, which is 0xa. And R2 is incremented, which is equal to 5, and R0 is equal to 6. So now again here, the counter is not equal to 0. So add these values again and again until it reaches 0. So once it reaches 0, it will come out of the loop. So let's see the same thing, how it is executed using the Keil Microvision. So once you open the Keil Microvision 4, go for project, new Microvision project, and give the file name and store it in any location, which is sum of integer. And this will be the project name, where I will save in the location or in a desktop. So let me save on the desktop. So now this target window, selecting the device target window will be displayed, where you have to go for the NXP and click on LPC2148. So that is the microcontroller we are using. So this will display the specifications of a microcontroller. Click on OK. For all the assembly language programs, you're not creating a startup code, so click on No. Now, the target is created. In order to write a program, go for File, New, and write a program. So, as discussed in the previous video, the area directive has to be written after a tab. The entry and start doesn't require a tab. And all these instructions to be executed have to be written under the code memory. So once the program is written, save the program and give the name with extension .asm, that is sum.asm. So I'm going to save it in the same location. Now, once you are saving the program, go for source group, right click and select add files to group source group 1. Select, go to the desktop. So here I can find, here select ASM files. So here it will display the sum.asm. Select, add, and close. So check here whether the source group is added. So it is added. Now build the target in order to check for errors and warnings. So it is displaying 0 error and 0 warning. Next, after completion of this, you have to debug the code in order to see the output. So debug, start and stop debug session. Click on OK. So initially, all the register values will be equal to 0. And this arrow indicates it is the start of execution of the instruction starting from this counter. So when you click on this step-by-step execution, it is entering into the next instruction. So after the execution of this instruction, R0 is equal to A, 10 in decimal, A in hexadecimal. Next, click on next instruction. So you'll be having, that is R2 is equal to 1. That is the first integer number will be taken into R2. So it will continue until the R0, that is counter, reaches 0. So now you have 8, 7. So it is taking 1 plus 2 and adding and storing the result into the register R1. So once it reaches 0, the result that will be displayed in register R1 is 37. This is the result, so which we are having. So until the counter reaches 0, it will be executing the loop next or the label next, which are these 3 instructions like add R1, R1, R2, add R2, #1, and subtract, and it will go on continuing the loop. Thank you for watching this video. please watch the upcoming videos. Thank you. Thank you all.